Hey everybody, in this video we're going to start wrapping up our geometric sequence talk here. We're going to look at a table and then we're going to look at geometric sequence that is in a graph only, and we'll write an interim formula for it. Okay, so let's get started looking at some of this. Okay, so we're given a geometric sequence, or it doesn't say that necessarily. We don't know what kind of sequence this is without a quick investigation, right? We test it. Is it arithmetic? We say 6 minus 2 is 4. 18 minus 6 is not 4, not arithmetic. And we start dividing. 6 divided by 2 is 3. 18 divided by 6 is 3. 54 divided by 18 is also 3. This tests positive for geometric. And if we look down here, it's going up in increments of 1. 1, 2, 3, 4. Now it doesn't have to start at 1 in a table. And we'll maybe talk about that in one of our discussions. So let's take a look at what we would do with this. We have a 2, 6, 18, 54 sequence, and we need to write a formula for the nth term, say. Or maybe we're asked to make a prediction further down the sequence. And we have 2, 6, 18, 54, and so on. That's really what your sequence is. And I pulled that out of the f of n column. Those are your output values. Those are your terms of your sequence. All right, so it's going to be pretty simple to write. We're going to write f of n equals. Now we're going to run a quick calculation for r. It's 3. So we have 2 times 3 to the n minus 1. So we come from our table to make light work out of this thing, right? Pretty easy. So if you see a table, you can write it from a table just as easy. All right, let's take a look at this next little problem I have here. And I think I like this one a little more. It's a little more fun. All right, this time, and I know this might be kind of hard to see. A geometric sequence is a discrete function whose domain is a set of natural numbers. Okay, that's true. That's why the graph looks like this. So if you're plotting terms of a sequence, here's what you got to wrap your head around. If you're looking here on what normally would be our x-axis, we call this the n-axis in sequence, a graph of a sequence, and this would be your f of n axis. And if we look at n is equal to 1, 1, 2 is what we get right here. All right, so the term of that sequence is 2. If n is 2, that's the next term, it looks like we get 4. Kind of hard to see, I realize that. At 3, it looks like we get 8, and so on. And if you look at this guy, I believe he's at 16, and so on. So what we're looking at on this axis are the outputs. These are the terms of the sequence. There's that 2, 4, and these are just the inputs. Now, when they say discrete, you cannot connect these dots. There is nothing in between 1 and 2. There's not the 1.5th term. There's no such thing. There's not the 0th term. Not the 2.2th term. That doesn't even make sense, right? If I'm counting tables in my classroom, I don't go 1, 1.2, 1.3. No, there's either a table there or it's not there. 1, 2, 3, 4, 5. Those are discrete items, right? And I got another video coming up later where we're going to compare these to functions of real numbers, so we're not going to get into all that here. So I think the biggest thing we want to do here is just write a formula for the nth term. And let's get in here and see what we can come up with. The first thing we got to realize is when we were looking at that thing along the n-axis, we went out to 4, I think. We found that if n was 1, f of n was 2. If n was 2, we had a 4, an 8, and then a 16. So there's my sequence, right? And we could even put commas here, right? And I'll even put a dot, dot, dot. And we looks like a geometric sequence. 4 divided by 2 is 2. 8 divided by 4 is 2. 16 divided by 8 is 2. So we know our first term is 2. R is also 2. So our nth term formula is pretty simple. 2 times 2 to the n minus 1. Just for you guys wondering, this is also 2 to the n. That will also give you your sequence. This can be combined using our exponent rules that we're going to study. And we probably need to jump into some of that inside this unit. Sometimes I feel like this is in a strange order. We should have probably looked at some of that. All right, so this right here can be simplified to this. This would be okay with me. I will accept that since we haven't really dug into the exponent rules yet. But this will produce your same sequence. See, if you put in 1, you get 2. You put in 2, you get 4, and so on. All right, so that's finding a sequence from a table and finding a sequence from a geometric sequence from a graph. All right, so I'm going to talk on the next video about recursively defined sequences or geometric sequences. So I'm going to stop this video right here, and I'll get back to you in the next one. Hope that's helpful for you guys.